Dear students, in this part we will learn properties of whole numbers, estimate numbers and patterns on whole numbers. Let us start with the properties of whole numbers. Properties of whole numbers. There are 5 properties of whole numbers. Closure property of addition and multiplication. Commutative property of addition and multiplication, associative property, distributive property and identity property. Let us learn one by one property with the examples.
Closure property of addition. When two whole numbers are added, we always get the sum as a whole number. For example, 5 plus 6 is equal to 11, which is a whole number. Closure property of multiplication. When two whole numbers are multiplied, we always get the product as a whole number. For example, 3 multiplied by 9 is equal to 27, which is a whole number. Commutative property of addition. Prabha and Manoj were putting wallpapers to decorate their room. Prabha has 4 blue patterns and 2 green patterns. Manoj has 2 blue patterns and 4 green patterns. They want to put all the wallpaper pieces on the wall. How many wallpaper pieces has each of them put? Let us look at some examples of addition. Observe that the sum of two whole numbers is the same irrespective of the order of the addends. This property is called as commutative property of addition. Thus, Prabha and Manoj both have put same number of wallpaper pieces. Let us take an example. Add 380 plus 244. Using commutative property, we can write 380 plus 244 is equal to 244 plus 380. 380 plus 244 is equal to 624. 244 plus 380 is equal to 624. So, we can conclude that even if we change the order of the addends, the sum remains the same. Commutative property of multiplication. Prabha has 6 blue wallpaper pieces in each of the 3 walls, and Manoj has put 3 wallpaper pieces in each of the 6 walls of the house. How many wallpaper pieces has each of them put? Let us look at some examples of multiplication. Observe that the product of two whole numbers is the same irrespective of the order of the factors. This property is called as commutative property of multiplication. Thus, Prabha and Manoj both have put same number of wallpaper pieces. Let us take an example. Multiply using commutative property. 312 into 120 is equal to 120 into 312. 312 into 120 is equal to 37,440. 120 into 312 is equal to 37,440. So, we can conclude that even if we change the order of the multiplicants, the product remains the same. Commutative property of subtraction. Prabha has 36 wallpaper pieces. They need 63 pieces of wallpaper to cover the wall entirely. How many more wallpapers are needed? Will the result of the subtraction remain same if the orders of the numbers are changed? The result is not the same in both the cases. As we can see that the result of the subtraction is not the same. Therefore, we say that commutative property does not hold true for subtraction of whole numbers. Commutative property of division. Now, let us see. Prabha and Manoj want to put 32 wallpapers equally in 4 walls. How many wallpapers should they put in each wall? Will the result of the division remain same if they change the order of the numbers? As we see that the results differ as the order of the numbers are changed. Therefore, we say that commutative property does not hold true for division. Associative property of addition and multiplication. If 3 whole numbers are to be added, the sum will be the same even if the order of the numbers is changed. Similarly, if 3 whole numbers are to be multiplied, the product will be the same even if the order of numbers are changed. Thus, associative property of addition and multiplication holds true for whole numbers. Let us see how this property works in making our calculation easier. Example: add 44 plus 60 plus 24. To add these 3 numbers, we can associate the last 2 numbers. That is 44 plus in bracket 60 plus 24 is equal to 44 plus 84, which gives 128. To add these 3 numbers, we can also associate the first 2 numbers. That is 44 plus 60 in bracket plus 24 is equal to 104 plus 24, which also gives 128. In both the cases, the sum is the same, which is equal to 128. So, we can conclude that if 3 or more whole numbers are to be added, the sum will be the same even if the order of the numbers are changed. Let us now see how associative property of multiplication makes our calculation easier. Example 2. Multiply 12 into 10 into 42. To multiply these 3 numbers, we can associate the last 2 numbers. That is 10 multiplied by 42 in bracket multiplied by 12, which is equal to 12 multiplied by 420, which gives 5040. To multiply these 3 numbers, we can also associate the first 2 numbers. That is 12 multiplied by 10 in bracket multiplied by 42, which is equal to 120 multiplied by 42, which gives 5040. In both the cases, the product is same, which is equal to 5040. So, we can conclude that if 3 or more whole numbers are to be multiplied, the product will be the same even if the order of the numbers are changed. Distributive property of multiplication over addition. Let us understand how distributive property is used to simplify our calculation. We know that the multiplication problem 6 multiplied by 9 also means 6 rows of 9. This grid represents an array of 6 rows of 9. We can find the product of 6 and 9 by counting the number of boxes in the grid. We see that there are 54 boxes in the grid. Therefore, 6 multiplied by 9 equals 54. Let us see how further we can simplify this multiplication. For this, we can write the statement 6 multiplied by 9 as 6 multiplied by 5 plus 4. That is, we break the second number, that is 9, into two parts, 5 and 4. We can show this in our grid by breaking the whole grid in two parts. The bigger rectangle still has 6 rows, but it has now 5 columns. Similarly, the smaller rectangle has 6 rows and 4 columns. We can solve this by counting the number of boxes in each rectangle. We know that 6 rows of 5 columns will result to 30 as a product. Similarly, we know that 6 rows of 4 columns will result to 24 as a product. Thus, 30 plus 24 gives 54. This means 6 multiplied by 9 can be written as 6 multiplied by 5 plus 4. Let us see how we can apply the distributive property in solving a multiplication problem. Multiply 212 into 155. We are already aware of the usual way of multiplying two numbers. The other way is by using the property. We can break the number 155 into three parts as 100, 50 and 5, which we can write inside the bracket. We then multiply the numbers in parts, that is 212 multiplied by 100 plus 212 multiplied by 50 plus 212 multiplied by 5, which is equal to 21,200 plus 10,600 plus 1,060, which is equal to 32,860. Thus, we can see that our calculation becomes much easier by using the property. Identity properties. Let us see the different identity properties for addition and multiplication. 1. Adding 0 to a whole number gives the number itself. For example, 2,345 plus 0 is equal to 2,345. We call 0 the identity for addition or additive identity for the whole number. 2. Multiplying any whole number to 0 gives the product as 0. For example, 678 into 0 is equal to 0. 3. Multiplying a whole number by 1 gives the product as the number itself. For example, 9,200 into 1 is equal to 9,200. We call 1 the identity for multiplication or multiplicative identity for the whole number. Let us do a quick recap of what we have studied till now. Remember, 1. In commutative property, we can move the numbers to make convenient pairs for easy addition. 2. In associative property, we can group the addends or multiplicants in such a way that the operation is easier and faster. 3. The distributive property of multiplication over addition simplifies the process of multiplication.
We have already learned how to round up the numbers. Based on the same concept, we will learn estimation. The process of finding an approximate value made by observation is called estimation. In our daily life, there are many occasions where estimation is required. For example, the amount of rice required to feed 100 people. The household budget for a month. Let us quickly solve the examples to understand the estimation of addition, subtraction and multiplication.
Let us quickly solve one more example. Here, to estimate the sum, round off the numbers to the nearest thousand. So 6,524 is rounded off to 7,000. And 3,171 is rounded off to 3,000. Thus, the estimated sum is equal to 7,000 plus 3,000, which is equal to 10,000. Now, let us find the actual sum. So, 6,524 plus 3,171 is equal to 9,695. Kids, solve one more example. Here, to estimate the difference, round off the numbers to the nearest thousand. So, 7,328 is rounded off to 7,000. And 4,142 is rounded off to 4,000. Thus, the estimated difference is equal to 7,000 minus 4,000, which is equal to 3,000. Now, let us find the actual difference. So, 7,328 minus 4,142 is equal to 3,186. Kids, why not you all try solving a few examples on your own?
Estimating the product. Let us estimate the product of 5,965 and 4,958 by rounding off each number to the nearest thousand. Here, to estimate the product, we round off the digits to the nearest thousand. So, 5,965 is rounded off to 6,000 and 4,958 is rounded off to 5,000. Now, let us multiply the numbers obtained to get the estimated product. Thus, the estimated product is equal to 6,000 multiplied by 5,000, which is equal to 3 crore. Estimating the quotient. Let us estimate the quotient for 77,439 divided by 1,125 by rounding off each number to its greatest place. The number 77,439 is rounded off to the nearest 10,000. We get 80,000. 1,125 is rounded off to the nearest thousand, and we get 1,000. Hence, the estimated quotient is equal to 80,000 divided by 1,000, which is equal to 80.
Patterns in whole numbers. Numbers can be arranged in some elementary shapes using dots. The shape could be a line, square, rectangle, triangle. Every number can be arranged as a line. For example, some numbers can be arranged as squares. For example, some numbers can be arranged as rectangles. Rectangles can be horizontal arrangement or a vertical arrangement. For example, some numbers can be arranged as a triangle. For example, sometimes some kind of pattern is observed in whole numbers which can help in simplifying the calculation process. For example, let's look at another one. One more example.
Thanks for watching. Be happy and take care.